Is the screen visible? Hello?
Yes, yes, ma'am, visible.
Yes. So we'll start for the mechanics of fiber reinforced polymer composite structure, and this is the live interactive session number 7 by me, Anya Mandal. So we will discuss some sample problems for the next assignment. So first question is, in the ABBD matrix of an antisymmetric laminate, so which of these options are correct? So an antisymmetric laminate is one in which there are always plus and minus theta of a laminate. It is another type of balanced, but antisymmetric laminates, it has both theta plus and minus, but they are not symmetric. So there will be present a plus and minus at certain height from the middle point, but only those two layers will have the same thickness and same position, and other all layers we are not considering in an antisymmetric laminate. And it is same as a balanced laminate. So as we know, in a balanced laminate, when there is when there is a stress given in one direction, then there will be equal stress shear in uh, uh, sorry. So in balanced laminate, what happens? A16 and A26 is equal to 0. Why it is equal to 0? Because the Q matrix that is formed for the laminate, in that the coefficient Q16 and Q26 will be in such a way that they will go opposite to each other, because there is a plus and a minus. So Q for plus theta will be equal to minus of Q of minus theta. Because of that, when we are doing summation here for the A matrix, it will be equal to 0. Similarly, for the D matrix, here also the Q16 of positive theta will be equal to minus of the negative theta. Because of that, when there will be a summation, the D matrix will also be 0. But here it is not symmetric matrix. So when there is a symmetric matrix, at that case the B matrix is equal to 0. But for antisymmetric laminates, the B matrix will not be 0. Therefore, only the first option will be correct, that is A16 equal to A26 equal to 0, and D16 and D26 is equal to 0. So next is, which of the following is a quasi-isotropic laminate? So sir taught in class that quasi-isotropic laminates are those in which it has more than 3 number of laminates, and the orientation of the adjacent layers are such that it is the orientation is equal to pi upon n, where n is the number of layers. So in the options, you can see all of them has 4 layers. So pi divided by 4 will be 45. So the adjacent layers orientation should be such that they have a difference of 45 degree. So only the second option is the one in which there is 0, then there is 45, then minus 45, and then 90. So they have a difference of 45 degree among them. Therefore, this is the option which will be correct. Next is, in the ABBD matrix of a quasi-isotropic laminate, which of the following is true? So a quasi-isotropic laminate is results when the individual lamina is oriented in such a manner that it produces an isotropic matrix. So each of the laminas are producing their orientation combines into a manner that the whole matrix of that laminate will be isotropic. So now for isotropic, the matrix is in such a way that A11 is equal to A22, and the A A11 is equal to A22. So the first and third and fourth, first and third option, you can see A1 was equal to A22. Then next is the A16, which is this one, and A26, they are equal to 0. So here you can see A16 equal to A26 is equal to 0, and the third is A66 is equal to A11 minus A12 divided by 2. So the first option will be correct. It is just matching with the isotropic matrix that we have studied before. So this is the option. Next is for a symmetric laminate, the effective extension Young's moduli are given. Ex equal to 30 gigapascal and Ey is given 10 gigapascal. If the effective in-plane Poisson ratio of the laminate is mu xy equal to 0.3, then what is the value of effective in-plane Poisson ratio mu yx? So already sir taught in the class there is a relation between mu xy and mu yx with respect to the Young's moduli in x and y direction. So this is the equation. So we will put the values in that equation and we can get from the values of mu xy, ex and ey, we can get the value of mu yx. The next question is a 0 plus 45 minus 45 90 symmetric laminate is subjected to only nx and ny, and the stresses at the mid of top 0% ply was found to be sigma x, sigma y and tau xy given. If the same nx and ny applied to another laminate made from same lamina but with the stocking sequence 0 plus 45 minus 45 90 2s, so that the number of laminae is doubled. The stresses at the mid of the top 0-degree ply will be what? So here you can see the total number of laminas are doubling. So when we will first we have to calculate the A matrix. So A matrix equation is this. So if the number of laminae are doubling, then the values of the matrix A will also double according to this equation. Now the relation between n, the strength and the strain is given by this equation. You can see. So here if A, the whole A matrix is double. So when we want to, we will convert it into the form of strain. We can see we are inversing the whole A matrix. So initially it was double. Now it will be half. So now the strain is half. So accordingly, the stress will also be half for the same moduli. So here the values are given, initial values like sigma x is 20, sigma y 5 and tau xy 0. So now they are getting half because it got inversed here. So we will take the values, half of them, that is sigma x will be 10, sigma y will be 2.5 and tau xy will be equal to 0. Next question is, the reduced stiffness matrix for unidirectional graphite epoxy lamina is given. So if a 090 symmetric laminate made from unidirectional graphite epoxy lamina with lamina thickness of 0.1 mm is subjected to an in-plane load of Nx 100 Newton per meter, the global axis strains induced in each ply will be. So first of all, we will understand how the sequence of the laminae are. It is 090 symmetric, which means there are 4 lamina. 2 of them are 0 and 2 of them are 90 and they are symmetric to each other. So when we are given the Q value, matrix, we can consider it of 0 or the 90. As you know, the orientation of 0 and 90 is perpendicular to each other. So if we consider this Q matrix is for 0, then for 90 the orientation will be such that the longitudinal strength will become the transverse of the other one. Because of that, the q, if we consider this q for 0 degree, for 90 the a11 the q11 and q22 will inverse, because the orientation of 0 and 90 are perpendicular to each other. So their transverse and longitudinal forces will be interchanging. So using that concept, well, let's see the question. So we are given the q of one value, we have to find first the A matrix. Now to find the A matrix of the whole laminate, first we know there are 2 laminas of 0 degree and 2 of 90. So we are taking q of this as suppose 90. So it is okay. So this is for 90 and there are 2 of them. So into 2 into the thickness. So thickness is given 0.1 mm is same for all of them, and then there is a unit conversion. Plus for the 0 degree fiber orientation, again there are two of them. So 2, and the Q matrix, the Q11 and Q2 are interchanged and into the thickness, and again the conversion of the units. From that we will get the total A matrix. Now this is the laminate is symmetric, therefore the B matrix will be equal to 0. So we will find the mid surface strain equation like this. As I showed before also, we can find the mid surface strains as A matrix inverse and the in plane load value. So only nx is given, so we will take others as 0, and we already got the A matrix. We will take inverse of that, and we can get the mid surface strain values of the global axis. The next question is, the reduced stiffness matrix of unidirectional graphite epoxy lamina is given, and the coefficient of thermal expansion of unidirectional graphite epoxy lamina are given, alpha 1 and alpha 2. There in the if a 090 symmetric laminate made from unidirectional graphite epoxy lamina with lamina thickness of 0.1 mm is subjected to only a thermal gradient of 50 degrees Celsius. In the global axis, residual thermal strain in 0 degree lamina R. So here we have to find the global axis residual thermal strain. So what will be the steps? So first, again like the last question, the Q is given and the laminates are in such a way that it's 090 symmetric. So from the same concept we used in the last question, we can find the A matrix here. So we will find the A matrix and then keep it aside. Then next is thermal coefficient transformation. So we are given the we have to transform the values of alpha 1 and alpha 2 into the global axis by this transforming matrix. From that we will get alpha x, alpha y, alpha xy values in the global axis. The next is we have to find residual thermal strain. So finding residual thermal strain, we have to find what will be the free thermal strain of each of the plies. So for that, sir has residual thermal strain means it is the difference between when the laminates are attached to each other and when they have no such bonding with the other laminates, so they are free. So when they are subtracted from each other, we can get the residual strains. So for that we need the free thermal strain of each ply that can be found from the delta T and the thermal expansion coefficients in the global axis. Okay, then we will get the strains, the free strains in global axis. Next, we have to find the global strain for the laminate as a whole. So we got the free strains. Now we need for the whole laminate. For that, the equation was given in sir has taught in the class. For every laminate, you have to find the Q matrix and then multiply with the coefficient in the global, and from this equation you can get the global strain for the laminate as a whole. So when we found that, we will subtract it with the residual free thermal strains, and we will finally get the residual strain in the global axis. Any doubts? Nagendra Babu?
Good evening, madam.
Good evening.
Madam, a small doubt, madam. For calculating the A matrix, we are using the thickness of the laminate.
Where? Which question?
Here.
Clear. It's not audible properly. Can you write it in the message? What is your question?
Okay, madam.
Are you typing the question, Nagendra?
Hello. Actually, up to question number 7, I was there. After that, I got internet problem. Uh, After 7, question number 7, did you go for question number 8 like that?
No, 7 was the last question.
Okay, okay, okay. Thank you.
So do you have any doubts till then?
No, today's problem, I don't have any doubts. Then assignment questions I not solved it. This time I got late. So tomorrow, day after tomorrow, I will try.
Nagendra Babu, uh, are you typing your question or okay, ZK and ZK minus 1 is the thickness of the laminate. So it is given in the question what is the thickness. So that is the ZK and ZK minus value. Means ZK minus ZK, ZK minus ZK minus 1. So for that thickness you have to take.
Okay, madam. For 0 and 90 degrees lamina, you can take a top side of 5 or
I remember.
for top side, madam. For suppose it is a 0 degrees and 90 degrees lamina, you can consider the positive value above or below.
It's like there is a 0 point in the middle, and then at some k point and k minus 1 is the point above the lamina. So if you take the difference of that, that will be the thickness of that laminate. laminae, one single lamina. So that is what it is saying. It's like from point 0, you one point that you consider as k, and then there is k minus 1, which is another point which is at the next laminae. So difference of that will be this, which will be thickness. Okay, then we will stop this session here. Thank you.